So hello everyone, welcome to this new session. So in the last session we have discussed the concept related to signal flow graph, right? So without wasting any time, we are going to solve one problem related to this signal flow graph. So this is a very simple and basic problem. Okay, you will understand it in a very quick manner, and we don't have many much steps and all, means this won't take many pages. If you know the concept very well, this is very easy to solve. Okay, yeah, you need to be very you need to concentrate very, and you need to be very sharp in these kind of problems. Okay, while checking the loops, forward paths and all. So yeah, so let's start with the problem here. So the given question is, to the signal flow graph given below, determine the transfer function C of S by R of S using Mason's gain formula. We know that we have this Mason's gain formula also, and we have discussed the terms Pk, delta K and delta, and what does those terms mean. Okay, during my explanation I have told you. So yeah, so now this is a simple signal flow graph given here. So first thing, in formula we need to know that what is K. The K is considered as number of forward paths. Okay, so here first we need to be calculating the forward path gains here. So we need to first know how many forward paths are there in this problem. Okay, so let's start with the counting of forward paths. So first simple forward path you can see is here 1 into G1 into G2 into 1 from input to output. Correct? We have one forward path, so let's name that forward path as P1. Okay, first we need to be calculating all the forward paths. Okay, yeah, P1. Okay, the first forward path I have told is 1 into G1 into G2 into 1. So that's one forward path from input to output, all the product of all the transmittances. Okay, so 1 into G1 into G2 into 1, that is also we can write it as G1 G2. So this is your first forward path, that is P1. So now second forward path here is, so we have one more forward path here, that is 1 G3 G4 and 1 into G3 into G4 into 1, since it's going in a same direction. See, you can see, right, same direction. Yeah, so the second forward path P2 is equal to G3 into G4. Okay, so we have one more forward path here, if you observe carefully, that is 1 into G1. We need to be checking the direction. Okay, it should be going in the same direction. 1 into G1 into G6 into G4 into 1 up to output. So you can see that we have one more forward path, right? 1 G1 G6 G4 1. So our third forward path is G1 G4 G6, right? Yeah, so we have one more forward path. So here we need to be very careful by checking the forward paths. Okay, so one more forward path is 1 into G3, and here from here we can go here, right, G5, and from here we can go here G2 1. Okay, that's the fourth forward path, that is G3 into G5 into G2. So these are the number of forward paths. We have 4 forward paths in this problem. Okay, yeah, since there are 4 forward paths, we can say that K is equal to 4. Since we know that K represents number of forward paths, we have 4 forward paths here. Okay, yeah. So now next thing is what we need to be finding out. There are loops. Let us see how many loops are there in this problem. So now first let's consider basic loops. That is, this is a single loop. You can see here, this is a loop here, right? From one node it is going and it is terminating again at the same node. So that is H1 into G2, that is the loop gain. So our first loop L1 is equal to minus H1 into G2, right? So let's see the second loop now. So here we have one more loop, right? So this is again one more loop, which starting at the it starts at this point, terminates at this point. So their transmittances we need to multiply. So we are getting minus H2 into G3, right? So we have one more loop here, that is, we can see that this is a loop here again, right? It starts at this point, goes here and comes back again, and again this is a loop here again. So their transmittances are G5 and G6, so G5 into G6. So here if we see whether is there any other loops here, so we have one more loop here, yes, L4, that is G1 G6 H2, right? It starts, see here, see carefully, it goes here G1, passes here again G6, same direction, and H2, and comes back to the same node again, right? Yeah, G1 G6 H2, that's another loop. And here we have minus H2, it would be minus G1 G6 H2. So similarly we have one more loop here, that is, which starts from here G4 H1 G6, right? See this point here, from this point it starts G4 this direction, H1 and G6, again it reaches the same node. Okay, so that's a loop again. So you need to be knowing you need to be having a very sharp mind by seeing the forward paths and loops, because if you miss any one of the forward path or loop, the whole problem would be wrong and you would be getting less marks. Okay, yeah, so there are totally 5 loops here, minus G4 H1 G6, right? Since we have here minus H1, so it would be minus G4 H1 G6. Okay, in total we have 5 loops and 4 forward paths. So there are we need to be checking again, cross checking again, okay, whether there are any other loops or forward paths. So let's cross check the forward paths right now. So first P1 we have told it as it is G1 G2, so yeah, G1 G2, yeah. P2 is G3 G4, that is G3 G4, correct. P3 is G1 G4 G6, G1 G1 G6 G4, correct. So P4 is G3 G5 G2. So yeah, there are only 4 forward paths and there are 5 loops. Okay, one is H1 G2, H2 G3, G5 G6, G1 G6 H2 and G4 H1 G6. Okay, so there are 5 loops and 4 forward paths. So now we need to be considering 2 non-touching loops. Okay, in order to calculate delta we need to be knowing this, right? 2 non-touching loops at a time. So here as you can see that we have 2 loops here, L1 and L2. So this is the loop L1 and loop L2. We can see that they are placed at 2 different corners and those 2 loops are non-touching. Okay, for this loop we have separate 2 nodes, and for this loop we have separate 2 nodes, and these 2 loops are non-touching. Okay, so first we need to be considering 2 at a time, right? So 2 non-touching loops we have L1 L2, and again we need to be checking whether we have a few more non-touching loops or not. So if you see in this problem, if we have only these 2 non-touching loops, rest all the loops are intersecting with each other. So we can say that we have only 2 non-touching loops. Okay, on 3 non-touching loops there are 0. Okay, 3 non-touching we have 0. We cannot take 3 at a time, since only we have these 2 loops which are non-touching. So 3 non-touching loops we have 0. So similar K, now we need to find delta K, right? And we have got the value of K as 4. So we need to be finding delta 1, delta 2, delta 3 as well as delta 4. Okay, the formula is 1 minus loop gains which do not touch the forward path. Okay, so here all the loops here are touching the forward paths here. Okay, so for delta 1 we need to be considering the first path P1, that is G1 G2. So in this path in this path all the loops are touching in this part, so we can say that there are no non-touching loop gains, so it is 0. 1 minus 0 is 1. Similarly goes for delta 2. For delta 2 we need to be considering the path P2, G3, G4. In G3, G4 again all the loops are touching, so in G3, G4 path all these loops are touching to this path, so that's why again it is 1 minus 0. So delta 3 means again P3, G1, G4, G6, G1, G6, G4. Again you can see that in this path all the loops are intersecting, so 1 minus 0 equal to 1 again, and for same goes for P4, so 1 minus 0 equal to 1. So now we have so now we need to be substituting all these in the formula. Okay, so our formula is C of S by R of S equal to Pk delta k, that is we have a k value as 4, so it will be P1 delta 1 plus P2 delta 2, P3 delta 3 plus P4 delta 4 divided by our delta. Delta is 1 minus summation of loop gains, right? Summation of loop gains, we have 5 loops, so L1 plus L2 plus L3 plus L4 plus L5, okay, plus summation of 2 non-touching loops taken 2 at a time, right? We have only one loop, right, taken 2 at a time, so it will be, we will be writing L1, L2. So this is your basic formula. So using this formula we need to be substituting all the terms and we need to be getting our final answer. Okay, yeah. So now nothing much to do, only the substitution part is remaining. Okay, so the forward path P1 forward path is G1, G2 into the value of delta 1, delta 2, delta 3, delta 4 are 1, so we can ignore them. So plus forward path P2 value is G3, G4, okay. P3 value is G1, G4, G6 plus the value of P4 is G3, G5, G2, okay, divided by 1 minus all the loop gains, that is L1, L2, L3, L4, L5 minus G2, G3 minus G2, H1 plus G5, G6, correct, right? L3 is equal to G5, G6 plus G1, G6, H2 minus G4, H1, G6 plus L1 into L2. So the value of L1 is G2, G3, value of L2 is G2, H1. If we multiply this, minus into minus is plus, so it would be, sorry, this is H2, G3, okay, not G2, G3, H2, G3. So our final answer is G2, G3, H1, H2, okay, yeah. So now again simplify this and get the final answer. So this is your final answer. So nothing much I've done, I've just multiplied minus term to all these terms here in the bracket and again written this as the final answer. So this is your required for transfer function C of S by R of S using Mason's chain formula. So here you can see that the steps are pretty simple. We have no much steps here. Just the thing is you need to be knowing that you need to be knowing how to find the forward paths and loops, and you need to be checking the signal flow graph diagrams very well. Okay, you need to be knowing how many loops are there, how many forward paths are there, how many we can take non-touching loops, 2 at a time, 3 at a time, and you need to apply all of them in the problems. Okay, and simplify. So this is your final answer here for this simple problem here. So again, as I told you, the problems are going to get tougher in the upcoming session. So that's all for this session. We had solved only one problem. So that's all. Thank you. Please do like, share, subscribe guys, and please give your opinions about how your how these sessions are going on for you guys. Okay, so please like, share, subscribe. Thank you.